All right, we are going to start with this graph. Do you recognize this graph? What type of graph is the black one that goes along here and then swoops up? Exponential graph. This one in particular is e to the x. So we're going to look at what happens when we do e to the x and the derivative. Whoa. Whoa. It just moves around. I think I have to hit this button. Here we go. Oh. Isn't that cool? Do you see what's happening? The derivative is the same function. This is the only function whose derivative is exactly the same as what you started with, which is pretty cool. So no matter which point you pick, the slope of that point is exactly the same as what that point was to begin with. Yes? Why does it do this? Well, we could... Well, other exponential ones are similar, but not quite perfect. E is the number that just works out perfectly. So that's why it's so important in calculus, and why you study it in pre-calculus, like where did this number e come from? And then, yeah, it's just cool that it does that. Can't explain why that's the number that does that. There's just one number whose derivative is itself, and it happens to be e. When we look at, we'll look at the other exponential ones in this course and see what the derivative of that is. And because we know the derivative of e to the x, we'll be able to figure those out. If we look at another graph we're going to be looking at today, do you recognize this graph? It's a logarithmic graph that has this shape. And this one in particular is the natural log. Just like e to the x has a nice derivative, the natural log also has a nice derivative. Now see if you can remember that graph. Yes. It is a 1 over x graph, but you only have half of it. Remember, 1 over x graph would also have the swooping on this side below, but you only have half of it because the natural log, or any log, is only defined when x is bigger than or equal to 0. So that's what we're going to be looking at today. We're going to be looking at the derivatives of exponential and log functions. And we just saw that the derivative of e to the x is e to the x. So it doesn't change, which can cause your brain to do some weird things when you're trying to figure this out. So if you have a constant in front of e to the x, like y equals 5 e to the x, well, constants don't affect anything, and then the derivative of e to the x is e to the x. Right? So this would be a case where it wouldn't be hard if I asked, oh, what's the second derivative? Ooh. Let's do the 100th derivative. Ooh. Nothing would change. If you had to work backwards, it wouldn't be too bad either. That would have stayed the same. But then working backwards here, you would have an x to the 5. And so what number would have to have been in front? A 3. Anything else we need to do this? Oh, add 19. Good. Or add any number. Or not add any number. It doesn't matter.